Hello, hello, hello. Welcome back to another live stream. Apologies if anyone was expecting a strict start time. I was a little bit delayed there. Hope you all enjoyed the extra hour of sleep. Today is Sunday, the 26th of October. I'm going to do today a live solve of the NSAA and the ENGAA for 2020. It's the first paper that I've done sort of post ESAT, but getting ready again for the ESAT cycle heading into January. I thought I'd keep going because people seem to find the techniques useful there. So I'll keep going and make sure I've covered all the publicly available papers, just demonstrating how you can use my techniques in your own preparation in order to sort of maximize your chances of doing well when the time arises. So in case anyone's new coming in for the January cycle, what I do here in my preparation, because ESAT is so fast, I like to train myself by doing the papers back to front, which means I'm facing the hardest questions first. And the skill I'm training is how to tactically skip questions. Because it's so fast, you need to make sure every second is spent doing work that's going to get you a mark. And so what you don't want to do is to waste your time, see the first question, it's really difficult, you waste 5 minutes on it, you get in a panic, you think it's not going well, it pressures all the other questions, and you don't show your best work. So what you'll see me do is skip a whole bunch of questions, be very, very tactical about what my first question is to set the tone, make sure it's going well, give me some flow, give me some confidence, and then I'll keep going. And I know for a fact they're going to get easier as I go because that's just how the paper is organized. But yeah, so it's just going to be me skipping the harder ones that I see first, waiting until the easier ones that I see, and then I'll have built up a time bank. Oh, speaking of time bank, I'll just have to do the splits on the table. It's fine. So I'll keep my split times just so I'm able to go through them. It's been a little while since I've done this, so I'll probably be a bit rusty with my technique. But even so, that's okay, because I think when I make mistakes, that's also instructive. And you can kind of think, all right, how can I adjust my process and learn from my own mistakes as well? So with that said, I've got the math 1 is going to be from NSAA. The math 2 is going to be from ENGAA. The physics is going to be from NSAA. I think I'm good to go. So I'll start. In fact, let me drop you over onto second screen and start sharing screen. We're going to show the entire screen so that you can get the paper and the whiteboard at the same time. Usual. Yep, all good. So we're going to start here. And one thing I think I'm going to start doing as well in the timestamps is highlighting specific skills that I think are important or specific questions that I think people might struggle with. So we're going to start here with the math 1. Just going to get my time up and ready to go. Let me think about how I'm going to do. I think, okay, this time I'm going to do split times as I'm going through. Okay. Right, I'm feeling good. Let's get into it. Ready and go. This looks like it will be fine, but it's not first question material. This also looks like it's just going to take time. This I can do. Okay, so 18 is going to be the first question. So 18. All right, so 2 vertices are at 1, 1 and 3, 5. So those can be the smallest square I can draw is with them on opposite sides. So that's 1, 1, 3, 5. It's 2 of their vertices. No. Okay, well, basically, what the smallest one. Oh, no, that was right. So the smallest one, so that's 1, 1. That's 3, 5. So the smallest is when they are like this, where the distance between is that, the primitives. So the distance between them is the root of 2 squared and 4 squared. So it's the root of 4 and 16, which is root 20, which is 2 root 5. So that's 2 root 5. And I know these are going to be, it's a scaled up 1, 1, root 2. So I have to divide by root 2. So it becomes root 10 and root 10. Yeah. So the perimeter of that is 4 root 10. And then the biggest one is when that is the side. So when 2 root 5, so instead where they're like this, where that's the point and that's the point, where again, that was your 2 root 5, where the perimeter there would be 8 root 5. So the difference between the largest and smallest, this feels like it's taking too long, and it is, but whatever, I'm nearly there. And I can take a 4 root 5 out of that and be left with a 2 minus root 2, which is D. Okay, split time, next. Okay, this is a very common question type. So I'll note this in the timestamp. So the two solutions that differ by 6. Well, the solutions for 17 are minus b plus or minus square root of b squared minus 4ac all over 2a. Now this, so twice this discriminant, twice the root over 4. So so that is the difference between the roots. Is 6. Cancel that down for 2. I'll go into this in more detail, and I'll probably select this for a specific video on common question types. So p squared plus 32, come on pen, come on pen, 144. So p squared equals 1, 1, 2. That looks like a 4 can come out of that. So root of that is, let's take a 4 out, and you're going to get, well, that's going to be 80. No, so it's focus, Patrick. All right. 2 goes into that, the remainder of 3, which turns that into 8, which I can take another 2 out and make that 4 root 7, which is B. Okay. $16. Keep sharp, keep sharp. Warming up into this, but I got to keep focus. 2 identical 6 face die. Both are thrown, and the number is recorded. They're both thrown again. Okay, so this is binomial. So you're throwing it 4 times. The probability of being even is a half. So the probability of at least 1 is 1 minus the probability of 0, which is 1 minus the probability of them all being odd, which is a 2 to the 4, which is a 16th, so 15 over 16, if I've understood the premise of the question correctly. Yeah. Okay. Okay, so I'm going to zoom out here. I'm just going to solve it and then get the solution in there just so I can keep the diagram nice and big. So for 15, PS is X, PQ is, that's Y, that's Z. That's a straight line. Which is an expression for Z? Well, QS here is, okay, so sine 61 is opposite over Z. So Z is equal to QS over sine 61. And that is the root of y squared minus x squared over sine 61, which is F. Okay, so note it down. I think that is definitely the correct solution. 14. Red to blue, blue to yellow, red to yellow is that. What's the value P? Okay, so red to blue. So let's red to blue to yellow this. So red to blue is 18 to 5 individually. Blue to yellow is P to 3 individually. Red to yellow is 12 to 5 individually. So I need to make these whole. So this needs to be 5p to 15, and that becomes 15 if that's 36, which means I need to double this row and make it 36 to 10 to 15. where 10 is 5p, so p is equal to 2, which is A. I'll go through that probably. I'll do that slower when going through. 13. All prices are reduced by 25%. The resale price of a bicycle incorrectly by increasing the marked sale price. Okay, so what they did was it went to 75%, which is 3/4 X. And then they took 1/4 of that. In other words, what they did was they raised it so it becomes 5/4 times 3/4 X, which I really should have done straight up, is 15 over 16 X. Pen, come on. Okay. So now that's off by 1/16 X. And it's also off by 15. So X is equal to 15 times 16. So it's 225 plus another 15, which is E, 240. Pen is super laggy. Apologies for that. 12. The number of pair of boots is inversely proportional to the cube of the temperature. On a day where the outside temperature is that, if it's 700% more, that means that BT cubed is constant. So 250 pairs are sold when it's 8. So 700% more is obviously 7 times that. For T cubed, the 250s cancel. So T cubed equals 8 cubed over 7. So T is equal to 8 over the cube root of 7, which is C. Okay. So here, combining mean and age of the combined results. Okay, so let's combine these. So the total of that is 360. The total of this is 960. So that's the total, and you divide that by the total number here, and you'll get the new mean. Cancel the zeros. Let's cancel the 3's first. So that would become 12, and that would become 32. So the new mean should be 44. And the range has to be at least 21. The range can't get smaller. So I'm going to say 44 and range is bigger than or equal to 21, which is F. Okay. Okay, so A over B over C is equal to AC over B minus, and that becomes A over BC, that second one. So good use of fractions. So that's AC squared minus A all over BC, which is A into C squared minus 1 over BC. Come on. I don't know why the pen is so laggy today. Apologies. That's E. Okay, next. So 9, when the expression is written, completed the square form. Right, so let's just square everything out. Square the first, twice the middle 2 becomes 12x, and 9 minus, minus x squared minus 6x and 9. 9's cancel, so 3x squared plus 18x. That's what that becomes. So take a 3 out, x squared plus 6x, complete the square on that. You get x plus 3 squared minus 9. So not forgetting to multiply the 3 back in, minus 27. The value of r is minus 27, which is A. Okay. feel like I'm making good time, building up a good time bank here. So let me zoom in a bit more because I can. All right, question 8. What am I seeing here? Okay, let's make a substitution. So 2y squared, because those are the same thing, minus y minus 36 is 0. So my target number here is minus 72, which is 8 and 9. So I'm going to do 2y minus 9, 2y minus 8, and divide by 2. And that will become y minus 4 equals 0, which, yep, is how that goes. So y is equal to 9 over 2, or y is equal to 4. But that is x over 4 plus 3 is equal to these things. So x over 4, yeah, I'll just solve this properly, equals 3 over 2, cancels for 12 over 2, which is 6. So x is 6 on the first one, cancels for 1, and x equals 4 on the second one, and the sum of the solutions is 10, which is not an answer. I've got that wrong. Okay, let's, I'll come back to that with fresh eyes. I'm not going to let it panic me because I know I'm going to have time in my second pass to address that. Equilateral triangle, side length 8. Circle of center O passes through the vertices of the triangle. So apologies to this diagram. Circumference of the circle. Okay, so that's going to be 4. That's going to be 60. Okay, so this is a scaled up 30, 60, 90, which would be 1, 2, root 3. So I have to divide by root 3 and multiply by 4 on everything. So 4 multiplied by 4 over root 3 on all sides. So that gives us the lengths on those. We want to find, and that one here then becomes the radius. The circumference of the, oh, God damn it, I should have read the question. So we try that again. So what I should have done, if that's 4 and that's 60, then this radius, so sine 60 is 4 over r. So the radius is 4 over sine 60. And the circumference is 2 pi r, which is 8 pi over sine 60, which is b. Okay. And we're back in the game. Okay, considering these lines drawn. I forgot, so there are 20 questions, so I should have half an hour total. Forgot to check that before I started. Oops. Right, consider the 4 lines with the following equations. Which 2 are perpendicular? So the gradient on the first line is minus a third. The gradient on the second line is a third. Gradient on the third line is 3. And the fourth line is minus 2/3. 1 and 3 are perpendicular. That's B. Great. Not too stressful there. Gonna get a good gas. Oh, I thought I was gonna get a good gas law, but this is math 1. Right, so 5. Gas in the balloon gradually escapes as the volume decreases. 60% is lost each week, so it goes to 0.4 left after each week. What is the volume left after 3 weeks? Well, that cubed times 5,000. Nice. So that's 4 over 10. If I cube that times 5 times 1,000, the 10 cubed is going to cancel. So it's just going to be 64 times 5, which is 320, which is C. Okay. Ooh, apologies. Okay, so let me zoom out a little bit. Here, now what I'll do that in the analysis afterwards. So 4, that's the midpoint. Circular arc is drawn there. What's the area of the shaded region in terms of x, where x is the side length? So that's going to be a quarter. So where the radius is x, it's going to be a quarter of that circle. So it's going to be a quarter of pi x squared is the total And then I have to subtract this little semicircle, and that's going to be a half of pi, and that radius is x over 2. So you've got a quarter pi x squared minus an eighth pi x squared, which gives you an eighth pi x squared, which is a. Okay. Building up seconds. Let me zoom out a little bit. Okay, now that's fine. So each section is one number written on it. Spinner spun twice, and the two numbers scored and added. What is the probability that the sum of the two numbers is 5? Well, how am I going to get 5? I can only do it if the first, so that's the probability of 2, 3, and then 2, or the probability of 2 and 3. So 1, 2, 3, 4 out of 8. So there's a half of being 3, and there's 1 out of 8 being 2, and then the same thing in reverse. So it's a half of an eighth plus a half of an eighth, which is the whole of the eighth, which is a. Okay, good nth term is 2n plus 5. So if you're ever stuck here, just the best thing to do is to write out the first few terms of the series. So plugging in n equals 2, I'd get minus 1, then 3, etc. So term-to-term rule is you are adding 2 each time. And the term which has a value of 17, 2n is equal to 22, so n equals 11. And so adding 2 each time, and value, the 11th has that value, good. 1. Then I'll go back when I'm done. So for 1, 2 adults and 3 children is 20. 4 adults and 4 children is 34. So double that one up. 4 adults and 6 children is 40, which means that 2 children is equal to 8 and 1 child is equal to 4. So 4a plus 16 then is 34. I don't like subtracting that, but I think that means that 4a is equal to 18. Yes, it is. Yep. 2a is equal to 9, so a is equal to 4.5. Well, actually, it doesn't really matter, because if 2 adults is 9, then 6 adults is 27, and 2 children is 8, and you add these together and you get 35. How have I got that wrong? No, that's shameful. Hold on a minute. Double that up. 4 and 60 is 40. Oh my God, that's 6. Okay, so 6 and 20. No, but that doesn't hold anymore. So it was actually 6. And if I plug that in, that should have been 4a plus 24 is that. So 4a should have been 10. Hold on a minute. No, this is the end of the first pass. I'm getting this one right. How am I making such stupid execution errors? Restart. Okay. So that from that, 2c is that minus that, which is 6, which means that c is equal to 3. Plug that into here. 4a plus 12 is 34. 4a is 22, which is much more like it, which means that 2a is equal to 11 and 6a is equal to 33. So tripling that up. Adding the 2c back, adding those together, you get 39, which is D. Apologies for that. Oh, take a lap time. Cool. All right, let me go back through. Let me do this with fresh eyes. Got 10 minutes, which is good. I don't have any questions left. So let me try that again. So y is equal to x over 4 plus 3, which means that 2y squared minus y minus 36 is equal to 0. And I liked my factorization there, where it was minus 9 and plus 4. Oh, minus. Okay, I think I made a sign error. Okay, so y is 9 over 2, or y is equal to minus 4. So x over 4 plus 3 is 9 over 2. Subtract 3 from that, which is, so x over 4 is equal to 3 over 2. Multiply that up, you get 12 over 2, which is 6. And here, x over 4 plus 3 is equal to minus. I'm sure there's an easier way of doing this because I think the minus 3's will cancel, but I just want to be systematic here and say x is minus 28. Add those together, you get minus 22, which is f. Okay, that's much better. Got an answer, got an answer, got an answer. Yep. 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 Yeah. 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 All right. I think I just up 19, 20. Okay. And I've got 8 minutes, so I'm fine. And which means I can calm down now. So point M, point N. The line segment MN is transformed by 2 transformations. Let me draw it out. I can't see this. So we got 2, 5, and minus 3, minus 1. So the first thing we're going to do is to rotate 90 degrees clockwise about the origin. Okay, so what that's going to do is it's going to turn that into 5 minus 2. And it's going to turn that one, which was at minus 3, minus 1, into minus 1, 3. Okay, so that's where it goes after the rotation, which is RS. It's then translated by vector. Oh, I should really have just done the midpoint. Well, the midpoint of that is the average. That makes 4 divided by 2 is 2. That and that is 1, so that becomes a half, which is 0.5. And that has been translated by 5 minus 3, which is C, which I'm going to lock in. And then here, on question 20, let me just sort that out. So solid cone has a radius of x. The ratio of the perpendicular height of the cone to the radius of the cone is 5 over 2. So that becomes radius of the cone. So that is 5 over 2x. A solid hemisphere of radius y over 2. It's made from the same material. So the volume of that would be 4/3 pi r cubed, but if it's a hemisphere, so the volume of that is 2/3 pi r cubed, which is 2 pi y, well, 2 will cancel with that, so it's actually just cancels for 4 on the bottom, so it should be that over 12 is the volume of the hemisphere. The volume of this is 1/3 pi r cubed h, so volume is 1/3 pi, so pi r squared times h. So 5 over 6 pi x cubed. Oh, they even gave you those. Oops. Right, so volume of cone. Good to know I still know my formulas. So let's divide those through. You get 5 over 6 pi x cubed all over a 12th pi y cubed. Those will cancel. Multiply top and bottom by 12. And that will cancel to make 10. So it becomes 10x cubed over y cubed, which is d. Okay, so I've got a few minutes left. Let me just check and make sure I've answered every question. 1, 2, 3, 4, 5, 6, 7. I've lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 questions submitted. Right, I'm just going to stop the clock there. So that was good. So at 90 seconds a question, I finished with 4 minutes to spare. My initial reaction on finishing that is that seems to have been easier than what people went through in the October cycle for their Math 1. So I think they've probably stepped up their difficulty from here, from this first paper in 2020. I know the paper you see is like the hardest paper you're going to get. At least it feels that way. But like, I definitely think from feedback that Math 1 has gotten harder than that. So I would be suspicious of that. But let me go through, write down my split times and kind of analyze my performance now. So 18, let me just zoom this. No. All right, let me download it here. Uh, 18, I got D. Yep, my split time on that was 204. So I did take too long on that for a first pass. So I probably should have tactically skipped that as well, just in the interest of time, but I got it right. 17, I got B in 1 minute 30, which is bang on the money. 16, I got E correct, and I got that done in 54 seconds. So good time save. 15, I got done in 103. And I got F, which was correct. 14, I got done in 52 seconds. And I got A, which was correct. 13 was done in 112. And that was E, which was correct. Then I'll go through and see if I need to explain anything a bit more slowly. So 12 was 102, I think. Let me just check. Yep, 102. 12. Oh no, I got that wrong. That was B. I'll come back. I'll come back to that when I explain it. So I'll come back to 12. Well, in fact, if I'm going to do this, let me not mark it first up. Let me just write my split times down. So that was 102. This was minute on the money. This was 37 seconds. 9 I got done in a minute. 8 I got done, well, no, not 8 I got done the first time in 119. But then I didn't get an answer, so I have to add on what I got later. So then I spent 139 on this, 137 even. 137 spent on question 7. 38 seconds spent on 6. Then 50 seconds. Then I got that done in a minute. Question 3, I got done in 51.8 seconds. Nope, that's not how I write things. 51 seconds, right, then 42 seconds. And then question 1, because I got it so badly wrong, despite the fact it was such a basic simultaneous equations, it took me 2 minutes 10 to get that. Then going back from my other split times, the second time there, I spent a further 110 on it when I clocked the sign error. Again, I'll mark it up in a bit. Then it was 150 there. So that did take me a good time. Sorry, that took me time. So it was a good thing that I skipped it. And this final one, again, that took me time. So it was a good thing that I skipped it. So in terms of skipping, I probably should have just skipped the first question, but because what you really want is for your first pass, all of your split times to be less than 1 minute 30. And in your second pass, all your split times to be bigger than 1 minute 30. If in your first pass, your split times are too slow, it means you should be tactically skipping a bit more. But equally, if you are going to your second pass and you're smashing them out in 1 minute 30, either it indicates you should have done that in your first pass, or you say to yourself, actually, do you know what? That was still a good skip because I wasn't entirely convinced about like the content and I just wanted to find a better first question. So that's me analyzing the split times. Now let me go through and properly mark it, explain it in a bit more detail because I know I rushed some of these. So 18, D was correct. I'm still going to go through the question, see if I need to explain anything further. I think that was okay. So the thing to really understand about this is the scaling of the 1, 1, root 2 triangle. So this is a classic ESAT technique of your triangles and their scaling factors. So you either have your 1, 1, root 2 or you have your 1, 2, root 3, and they show up all the time, and being comfortable to take those out and use those is really important. The smallest one is going to be where they're on opposite corners, and then I scaled them down by dividing by root 2, which is how I got the perimeter. And that distance, the biggest triangle I can draw is when those are adjacent on the square. And so, yeah, I think that technique worked well, and I got it right, so that's good. 17. Okay, let me explain this in more detail because this is so classically ESAT, at least with the past papers. So the way that 17 works, we know that we have. We know that we have this quadratic equation. We know that x is equal, like I said over here, am I working? X is equal to this thing. So what it means is you're going to have this minimum point at p over 4. And the solutions are going to be that thing plus the root over 4, and that thing minus the root over 4. So if its solutions differ by 6, and I've seen so many of these questions, especially in these modern ESAT papers, the difference is going to be twice the square root then. So that's where I got this 2 square root over 4 is being the difference, and that difference is equal to 6. Now, I think you can also do this if you've done A-level further math using the roots of polynomials techniques, but Math 1 is supposed to be accessible to people who have not done further math, so I'm not going to use that further math technique here. From there, it's a case of just squaring up and being careful simplifying square root. Okay, so 16e I got correct. And I recognize this as binomial, which was the most obvious way I could do it. For fixed number of trials is 4, fixed probability of success is 1/2. Alternative, but the method was still the same. Definitely doing 1 minus 1/2 to the 4 to get that. 15 was this, and I think that was pretty self-explanatory. I think I explained that okay. 14a. Yeah, let me do this a bit slower. I definitely rushed this, and if you're not so good with ratios, because that ratios is a very classic ESAT technique, definitely worth going through a bit more slowly in case they're just not your cup of tea. So I did red to blue to yellow, and I said that was 18 to 5. And I said that was, and I'm going to leave a bit more room, that was P to 3, and a bit more room again, this was 12 to 5. In red to yellow. And what you want to do is in a combined ratio, you want to make sure all the numbers are the same. So the first thing I did was multiply this one by 5 to give me this, and multiply this one by 3 to give me this. Now the 15s are aligned. Now what I need to do is to double this up so that the reds are aligned. So that becomes 36 to 10. And then when I combine them all, that makes it 36 to 10 to 15, where the 10 is also 5p. And that's where p equals 2 comes from. So to get the combined ratios, scale them up so the numbers all are equivalent, and then just slot them together. Right. So that's 14. 13e was correct. I think that was self-explanatory. 12 was the one I got wrong. So let me see what my execution error was. Oh. Why? No. Okay, just didn't read the English language adequately. God damn it. Read the I keep on saying to my students as well, I it turns out questions are easier to answer when you actually read them, and it's just, "Yeah, I'm sorry. Yeah, I'm gonna use that on myself now. Yeah, egg on my face." It's not 700% of the previous day, it's 700% more than the previous day. So it's not that it's 7 times more than the previous day. The previous so what that means is 700% more. It becomes what it was before plus 700% of it before, so it ends up being 8 of what it was. So if I'd done this correctly, it should have been up until this point 8 times 250 times t cubed. Where that cancels. So 64 is t cubed, and t is 4, which is b. That I should have clocked that as a potential trap. Taking a bit more time to read that. Okay. So 11 was F. That was correct. I think that was these this is a pretty standard thing where you multiply those up to get the total of x, multiply that up to get the total of y, get the combined total and divide by the new total number of students, which is 30, using your classic ESAT skills for simplifying the fractions. Not too bad. The main thing about the range is if the range of the previous one is 20, you know that the biggest. So for instance, let me show you some possibilities for what could have happened with the range. So the range could have been between here and here on y. These 16 for x could have been within that. Or you could have had it where the 16 were outside of that. So the range can increase, but the range cannot get smaller because the total still includes this element here and this element here, which have a difference of 21. So the range cannot be less than 21 if all those elements are still included. Okay, so going to 10, it was E, which was correct. Yeah, people have some issues with fractions. Make sure you're good with fractions. So what you do here is you multiply. Well, in fact, the easiest way to think about simplifying a fraction on a fraction like this is to multiply here top and bottom by C to clear that one out, and here multiply top and bottom by B to clear that out. So the top becomes A and the bottom becomes BC. Never leave a fraction on a fraction. It's just bad form. And then from there, I think it was okay. Bring them to a common denominator. 9 was A. Yeah, nothing too bad. Just be careful with completing the square when there's a number in front of the x squared. A lot of people would have said -9 there, forgetting to multiply the 3 in. You could also have had some fun with this. I decided not to take the risk because ESAT is a very high pressure environment, but we could have, in fact, done the difference of two squares method. So that's equivalent to a squared minus b squared, which is obviously a plus b, a minus b. So adding them together, you would have gotten 3x by itself, and then an a minus b. So that minus that, you would have gotten x plus 6, which gets you to your 3x squared plus 18x. It wasn't actually a time save because I was needing to complete the square, so I had to fully expand it out anyway, but it might have saved a few seconds if it's something you're confident in. Eight, I've kind of beaten this one to death. I just made a sign error. Yep, I said it was, oh no. Oh, I should have, yeah. Sorry, it should have been -9 plus 8. So I just made a sign error when writing it down. Didn't panic on that because I knew I would have time to come back to it. It's all okay. So this one, I overdid it with the resolving triangle, finding the exact length. I should have looked at the multiple choice, realized they wanted it in terms of the trig, and just drawn the triangle from there. Once I spotted that, though, it wasn't too bad. Recognizing as well that okay, let me go into the circle theorem as to why this works. This line here of length A, which is the side of the equilateral triangle, is a chord of the circle. And I know that the perpendicular bisector of any chord of the circle goes through the center. So drawing a line from the center to there is a perpendicular bisector. That length becomes 2. That length angle becomes 90. And because it's bisected, and by symmetry, it's going to bisect that angle where that was a third of 360. So that was 120, and it gets split in half to form an angle of 60, which is where this triangle came from. From there, walk in the park. 6, bog standard. I don't think I need to explain that. I still need to mark it. Good. I didn't do anything silly. Classic cancellation here for C, which was correct. 4 was A, which was correct and not too complicated. 3 was A, and I remember that not being too complicated. 2, G, not too complicated. 1, D, not complicated if you do it correctly and do not make tiny execution errors. I still can't believe I just did that. Right. Okay, let's move on. So 8, when I got it, eventually I got F, which was correct. Oh no, it wouldn't. If it had been the difference, it would have. Okay, so just solve it. Don't try and do anything clever. Just see a path, do a path. That was fairly self-explanatory, I think. Let me get into this, where I think I could have done a more elegant path, but I got C, which was correct. So let me head back down to 19. So point M, I think what I could have done is instead of transforming the full thing, I could have just done the midpoint itself. If I recognized that that was the midpoint, if I'd spent longer reading the question, I could have got the midpoint from this, which would have been minus 0.5 and 2. I could have rotated just that point 90 degrees clockwise, which would have turned it into 2 0.5. And then translated it to there by going 5 and minus 3. So that would have been a much faster method. Now, you might be asking yourself how I was able to rotate at 90 degrees clockwise in my head so quickly. And the answer to that is, when I rotate 90 degrees clockwise, I know that 2 things are going to happen. I know that the X and the Y are going to swap around. And I know that one of the signs is going to flip. And I know this from experience. And you can get there if you've done, again, further math and you've done your matrices chapter. I won't go into it any further if you haven't done further math. What is going to happen is rotating 90 degrees clockwise, I knew that they were going to, so this was minus 0.5 and 2. And so I knew that you were going to swap those around. So that was going to be 2 and 0.5 with one of the signs being changed. And I decided that once I drew it, that they were both going to be positive. So for instance, here, I flipped those round in my head to give me 1 minus 3. And by rotating it kind of in my head, I knew it was going to be roughly there, which means that one is going to be minus. So with the numbers being 1 and 3, I know the negative sign is on the 1. X is negative here, Y is positive, and that affected my signs. For here, I had my 5 minus 2 originally. No, I had my 2, 5 originally. So again, flip those around, I'm going to have 5 and 2. And by rotating it, I know the X has to be positive, which is 5, and the Y has to be negative, which is minus 2. So because I know that kind of algorithm, I was able to rotate it quite quickly. So maybe worth sort of picking up if you didn't have that skill already. And then going into 20, I don't even think that was that complicated. Let me check I got it right. D, correct. You just apply the formula, nothing too complicated strategically there. Okay, so 19 out of 20, not a bad performance. It would have been 20 out of 20 if I'd read the question. So now, in fact, what I'm going to do, I didn't even get the, I'm going to end the screen real quick. I want to make sure I get the mark scheme up for the ENGAA 2020 for when it's time to go through that. ENGAA 2020. And I'll download that again. Okay, so I've got that ready for when I need it. Sharing screen again, we're going to go straight into the math 2. We're going to do the same thing. We're going to go from the back to incentivize me. Wait. All right, we're here for the, yes, I remember now. So we're going to go to section B, where we're going to be faced with only 10 questions because half of them are going to be physics. So I only have 15 minutes on the clock. I'm going to reset. Let me zoom in to make sure everything is okay here. That's fine. Maybe that's why my pen was lagging. I was too zoomed in. It's my story. I'm sticking with it. Right. So let's go. Maximum the gradient. I can do that. I fancy a crack at that. I trust this topic. So 40. So we're going to differentiate. We're going to get minus 4. Back to, oops, let me move that out of the way. So minus 4 plus, let me zoom in, powers plus, okay, so that times that is going to be 6 plus 6x to the half minus 2x. Doesn't equal 0 here. That's the gradient. We want to find the maximum value of that. So what we're going to do is we're going to differentiate that and set to 0. Or we're going to recognize this as self-quadratic. It's fine. So differentiate that. You get 3x to the minus a half minus 2 equals 0. So 3 over root x is equal to 2. So 3 over 2 is equal to root x. So x is equal to 9 over 4. We can plug that in here for the gradient and say that the gradient was minus 4 plus 6 times this thing. Root x was 3 over 2 minus 2 into 9 over 4. Cancels that for 2. Cancels that for 3. So it's minus 4. You can still see it. Good. Plus 9. Minus 9 over 2. Plus 9 minus 9 over 2 is just plus 9 over 2. That becomes, zoom down. So minus 8 over 2 plus 9 over 2 equals a half, which is C, and I'm locking it in. Okay. Ooh, that would be a good interview question. Right. I could just tell from going through it. So, okay, this, I'm going to bring the 2 out the front. So that's going to be 2 log x squared plus log x equals 3. So 4 log x squared. So I'm going to say plus that minus that is 0, where y is equal to log x. That is going to be minus 12, which is plus. So it's going to be, I think it's going to be 4y and y. It's going to be minus 3y and plus 1. Yep, that's the factorization. So log x is equal to 3/4, or log x is equal to minus 1, which has no solutions because log can lies. You cannot have the log of a negative number, but the log itself can be negative. So the product, so the product of the, so it equals 10 to the 3/4, x equals 10 to the minus 1. Multiply those together. You would add the powers together and get 10 to the minus 1/4, which is d. Okay. So far, so good. Here, top tip for anything here, replace that with c's and s's. So 14c cubed plus 10s squared c equals 13c. Now sine squared, as you know, is 1 minus cos squared. So you get 14 cos cubed plus 10c minus 10c cubed equals 13c. That makes 4c cubes left. Subtract that over, you get minus 3c. So you're going to get c into 4c squared minus 3. Oh, I see where this is going. So we get c into, so either cos is equal to 0 or cos squared is equal to 3 over 2, which means cos is equal to plus or minus root 3 over 2. So we know in the interval, okay, let's draw this out and be really careful now. So we know in the cos, nope, in the cos graph, nope, because I need it in the better interval, and in the full interval even, so it's going to be dupe. So the zeros, 1, 2, 3, 4 solutions for that, 4 for that, 4 for that, 12 in total is E. Okay. Don't need to know where they are, just need to know the number. 34, let's have a go. Two distinct turning points where the derivative is 0. Let's get it done. 6 root 5p plus 3p equals 0. Two distinct turning points. What are all the possible values of p? So two distinct turning points. Let me first divide through both sides by 3. X plus 3p. Nope, b plus p because I've divided by 3. Don't get distracted. And we know there are two distinct solutions to this quadratic, which means the discriminant is bigger than 0. Discriminant is b squared, so that is 20p squared minus 4ac has to be bigger than 0. So 4p into 5p minus 1 bigger than 0. So that if I draw that, it's a positive p squared, where the solutions are 0 and a fifth. And so p has to be less than 0 and bigger than 0.2, which is a. Okay. Two different geometric progressions. I know geometric progressions. So the third term of each. So ar squared is equal to 4. And ar4 is equal to 2. Divide that by that, we get that r squared is a half, which means the radius is plus or minus 1 over root 2. Difference between the sums to infinity. Okay, so we know if we divide by r squared, so we know that a has to be equal to 8 in both cases. So the difference between the sums to infinity, the bigger one, so 1, it's a over 1 minus r. And if you're dividing, so it's going to be that one, the difference over 1 plus 1 over root 2. Bring those to a common denominator. So on the top, you're going to get 8. Okay, let me do this a bit faster. So you're going to get 8 into 1 plus 1 over root 2 minus 8 into 1 minus 1 over root 2. And on the bottom, you're going to difference of 2 squares. Get that. So that's just going to be a half. So I'm going to multiply this by that, and I'm going to get 16 straight away. So it's 16 plus 8 root 2 minus 16 plus 8 root 2 is 16 root 2, which is E, and I'll do that a bit slower later. In the meantime, let's move on. Because I do not have a huge amount of time. 30 passes the 0.24. Positive, positive, passes through the 0.24. A line is drawn through to your point perpendicular to L. Triangle enclosed has an area of 5. Well, I know the height of that is 2. So area of 5 is a half base times height. So 5 is a half times base times the height of 2. So the base is, so that if that is C, then that is C plus 5. And we know the gradient of this line. So y equals negative 1 over mx plus c. For that one. Oh, I'm taking too long on this. Larger the two possible values of m. I'm going to go quadratic. I'm going to tactically skip. I'm burning too much time. I'm going to come back to that. I don't want to lose the possibility of doing the others. And I can pick that up where I left off. Okay, so 28. And I'm not afraid to do that as well. So 28. Some of the first 20 series of an arithmetic question is 50. Some of the next 20 is minus 50. Am I going to do this properly? No, I'm going to do this weirdly. So we know this is going down. And these are, so UN versus N, for instance. So what I know, I'm just going to do this. Okay, I'll do it the fast way, and then I'll do it a longer way later. So what this is telling me, I know they're all going down linearly. So I know that the sum of the, if the sum of the first 20 is 50 and the sum of the next is minus 50, then that sum has gone down by 100. And I know it's going to go down linearly. So the next 20 is going to be minus 150. The next 20 is going to be minus 250. The next 20 is going to be minus 350. The sum of these two cancel out. This then becomes minus 250 times 8, which is A. I apologize. I got the right answer, I think, but I can't explain what I thought, not quickly. I'd rather get the points, and then I'll go back and explain it later. So 26. Oh, this is easy. Non-zero gradient. So something like that. It's going to be reflected. It's going to look like that. That's going to still, it's going to be 1 over m. So because it's not m, but it's still positive, it's c. Cool. Build up a time bank. Love that for me. Okay, so here, area enclosed, it looks like it's going to be just basic integration. So y equals a half x and line y equals minus x. And x equals 1 and x equals 3. So that's going to be the integral of, I'm going to do integral of top minus bottom. So I'm going to do the integral of a half minus half x squared minus x is plus x. And I'm going to do that between 1 and 3 with respect to x. And that's going to be a 6x cubed plus a half x squared between 3 and 1, which makes that 27 over 6, which is 9 over 2. Plus, would you look at that, 9 over 2, minus a 6 plus a half, which is 3 over 6. So 9 over 2 is 9, minus 2/3, 26 equals 25 over 3, which is E. Okay. Not a huge amount of time. Both factors, which means that you plug in x equals 1, you get 0, 1 plus a plus b minus 12 plus 4 equals 0, a plus b minus 7 equals 0. Plug in 2. This is 16 plus 8a plus 4b minus 24 plus 4 equals 0. 8a plus 4b minus 4 equals 0. 2a plus b minus 1 equals 0. Well, double that up. 2, nope, don't double that up. Subtract them. That minus that is a. That minus that is 0. That minus that is plus 6. A equals minus 6. B equals 13. And that's B. 2 minutes left. Oh, that's it. Great. 2 minutes left to go back up and finish this. Let's go back to 30. Okay, so what do we know? We know it goes through that point. So we know that 4 is equal to 2m plus c. And we can also plug that in here. Let's plug in 4 and 2 into there. So we know that 4 is equal to minus 2 over m plus c plus 5. Simultaneous equations, we can solve for m and c. We want to solve for m, so we want to eliminate c. Let's subtract the two equations. So I'm going to do top minus bottom. That minus that is 0. That minus that is 2m plus 2 over m. That minus that gives me 0. That minus that gives me minus 5. Okay. Multiply by m. 2m squared minus 5m plus 2. So 2m, m minus 2 minus 1. M is a half, or m equals 2. So the larger is 2, which is d. And I have less than a minute left. I will take a lap time. I will just check I have all my answers. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 answers submitted. 30 seconds left. I'll stop it there. Okay, let me go through. And first of all, note down my split times. Right, so the first one I got done in 1 minute 32, so pretty much bang on the money. Then I was 117 here, which again is good for a first pass. Then 127, again, good for a first pass. So I'm pretty much bang on the money. Then 125. Then I have my slowest immediate split time of 1 minute 38, which is not bad for a slowest split. Then here, for the first time round, yeah, that was good. I got it. That was a good intuitive sense of when it was time to skip, because I was pretty much bang on the money of 130 skipping it the first time. Then we go here, where I take 133. So again, still a little bit over. It's really this 26 where I saved all the time. Got that done in 28 seconds. And again, this one was a bit intuitive, but I went for it. So we'll see if I got that right. So I didn't label it, but 112 was spent on this one. And then 58 seconds on that one. And then I went back to this and added a further. So it's a really good thing I didn't do this straight away, because the full solution path took me close to 4 minutes, which would have been way too long, and it would have made my other stuff time pressured. So even though I was doing good work that would have yielded a result, it was good that I skipped it when I did. And yeah, I felt no issue about cutting and running, because I know I left my work. I'd reached a kind of good checkpoint, so I know I could pick it up from that spot when I came back to it. Okay, let's go into the answers and see that I got them right, and I'll go through any explanations as well. So 40, I got C, which was correct. Does that need further work? Let's go back down. So for 40, just looks like a really fun question. I don't think that needs further work. That's the gradient, and we have to maximize the gradient. When you maximize anything, differentiate set to 0. Alternatively, I probably could have done it as a stealth quadratic and completed the square on it, which would have also worked. So demonstrating that path. From this point, you could have replaced that and said that was equal to minus 2y squared plus 6y minus 4, where y is equal to x to a half. Take a minus 2 out. Y squared minus 3y minus 4. So that's minus 2 into y minus 3 over 2 squared minus 9 over 4 minus 4. Put the minus 2 back in. It doesn't really matter about this, because we're only really interested in this. Oh, I wonder if I got it wrong. No, I didn't, because that's 9 over 2 minus 8 over 2, which gives you your plus a half as the gradient. So that was also available to you for minimizing a quadratic. Sometimes completing the square is faster. In this case, I decided to keep the ball rolling. Differentiated this set to 0 to find where x gets me the turning point on here. Plug that back in for the gradient and found it was a half, which was correct. All good. 38, I got D, which was correct. Do I need to explain further? Not really. A lot of people miss the fact that that 2 can come out the front. And then you can substitute and say y is equal to log x, and you just get a stealth quadratic. So not too bad there. 36, I really like this S and C method. 36, I got E, which was correct. Good use of the graph. And again, not finding where the solutions are, but just finding the number by sketching it out. 34, got A, which is correct. Good. Again, same thing, differentiate set to 0, simplify the quadratic, and there are 2 distinct turning points, which means there are 2 distinct places where the gradient is 0. So this quadratic, 2 distinct turning points, and the discriminant's bigger than 0. Just making sure not to execute that badly, and seeing quadratic inequality, always do that by sketching so that you don't make any small mistakes. Here, this wasn't too bad. It was just executing it. Here I simplified difference of 2 squares is x a plus b, a minus b. So when I multiply this together, it was going to be the first term squared, which is 1, and the second term squared, which is a half. So a minus a half is 1 minus a half, which is a half. Dividing by half, same as multiplying by 2. And then here, recognizing that 16 over root 2 is 16 times root 2 over 2, where those will cancel down to give me an 8, which is what I did mentally. Cancel that down. You get 32e, which is correct. Good. 30. I'm proud of this skip. I'm proud that I let myself skip that because and didn't sort of get sunk cost fallacy, thinking I had to get all the way to the end. I'd loosen the jam jar and I knew I could come back to it if and when I had time, but it wasn't worth sacrificing the possibilities for the other questions. I think this is explained all right. This is important. In coordinate geometry, when you want to find the area of a triangle, especially if it's a right angle triangle, a lot of people think you need to calculate those individual distances and do half base times height that way. A lot better to use your x and your y. So the base is the distance there on the y-axis, and the height is the distance there on the x-axis, which is 2. So 5 is a half times the height of 2, which obviously cancels times the base. So the base is 5. So if that's c plus 5. And from there, plug that in for the equation, and then substitute in both cases the fact that it goes through the point 2, 4. And then recognize this is your stealth quadratic. And if you multiply, if you multiply by m, you're going to get a simple quadratic, which gets you that. So this is an interesting solution path. Definitely worth practicing your coordinate geometry, making sure you're comfortable on those ideas. Now, 28. I would not have had time to do this fully. Did I get it right? Because I got an intuitive sense, but knew I couldn't explain it very well. 28a, yeah. Okay. Now, how we could have done this. We could have done it by saying the sum of that is, so 10 into 2a plus n minus 1d is 50. I suppose what you could have done is recognize that the next 20 terms is itself a simple arithmetic progression, but instead of having a, the first term is going to be the 21st term, which is a plus 20d. So this would have been 10 into 2, but instead of being 2a, it would have been a plus, hold on. Yeah, a plus 20d would have been the first. Plus 19d is minus 50. I suppose from there, we could have said 2a plus 40d plus 19d. And what you could have done from here is done 2a plus 19d plus 400d. The reason why that matters is because this thing is 50. And this thing, therefore, it's still taking me way too long, though. So that's your simple d equals minus a quarter. But I still don't really want to have to find a from that. It's just so long. But all right, cancel that down. That could have been 5. So 19d is equal to 5 minus 2a, which is 5 plus a half, which is 11 over 2. And you're not finding that difference. All right, so you weren't meant to do this analytically like that. I think because you'll see what I had an intuitive sense of is the fact that they are slowly dropping over time in that linear way means that. Okay, let me put it this way. So the sum of this is the sum of the terms from 1 to 20. And then the next one is the sum of all the terms from 20 to 40. Now, all of these are offset by 20d. Every single term is offset by 20d. And when you offset every single term by 20d and then sum them all up, you get minus 50. So what you know is any shift in the sum is the difference in those sums. The original terms will cancel it. This is why it's 400d. It's this 20d for all 20 terms. And so when I do that, when I drop every term by 20d, that causes a shift in the sum to go down 100. And what I recognized is going from 41 to 60 is going to be the same thing. I'm going to get that same drop of 20d in every single term. I say drop because d is negative, which would have made the drop in the total be exactly the same as minus 100, which is where I got these numbers from. I dropped 100, then dropped a further 100, then dropped a further 100, and these would have been the sums of all the other ones. And summing up all 5, then these cancel. You just get the sum of these, which is 750. I think that might even have been the intended solution path, in which case, absolutely no shame in skipping that. And if I didn't have an intuitive sense of that solution path, I would have skipped this, recognizing it would have taken too long to get through, and it wouldn't have been worth it as a first pass solve. But that was definitely the hardest question in the paper. This one was by far the easiest. 26C. Can you imagine if I got it wrong after saying that? I was like, no. No, we're good. We're good. No egg on my face this time. 24, did I integrate it correctly? Not too bad. And I got E. Yep. Alternative solution path. You could have done it as just the integral of the curve from 1 to 3. So 6 cubed from 3 to 1. So 6 into 27 minus a 6, which is 26 over 6, which is 13 over 3. So that there is your 13 over 3, and you could have added to that this trapezium, which is how you tend to do it in the textbook. So this would have been, and because it's y equals minus x, that's incredibly easy to say that. Change in y is 1, that's 3. Average is 2. Remembering that the area of a trapezium is the average of the parallel sides times the distance in between. So it would have been half into 1 and 3. So the average of those is 2, in other words, times the distance in between them, which is 2, which is so that area is 4. And you would have added that area to this area and gotten 25 over 3 again, which is E. That's the more intended solution path from your AS stuff. Taking the integral of the top curve minus the bottom curve is more what you do in your A-level work, your second year work. So it may not have been the intended solution path, but if it's a solution path you have and you prefer it, use it. This, I think, was just fairly self-explanatory. I hope I got it executed, and I did. I got B, and that's that. Okay, so let me wrap up now. Hopping over back into here for the physics. So, let me just make sure that's okay. I'm going to reset the clock and we're going to go again. So here, and let's go. So light spring, unstretched length, spring constant that. My brain is already going, this is not a first question. Skip. Okay, this is qualitative. I can do this. Burning fuel at a constant rate by expelling the burnt fuel through a nozzle. I know, I actually don't want to have to think about this too deep. Let's come back to that. I actually do like this. Let me have a go. I know it's weird, but I actually do. Because we know as it's falling, density of the metal, so it's going to be density times volume is the mass times g, that's the force down. The upthrust is the weight of the volume displaced, so that's density LVG, upthrust, and you're going to get the drag, which is KRV. Terminal velocity is when rho SVG equals rho LVG plus KRV. And that V is the terminal velocity. So rho S minus rho LVG all over KR equals V. VG S minus L over KR equals V, which is, that's option G. So I'm locking that in. Okay. Okay, so 37. Mass 80 kilograms drops from a plane traveling at 40 meters per second. So the energy before we can calculate is kinetic and GPE. Is the ground at a speed of 5. So what's the energy before? What's the energy after? That difference is the work done. So the energy before is a half v squared plus mgh. So cancels that for 40. So it becomes 40 cubed effectively, which is 64 with 3 zeros. And this becomes 16 with 1, 2, 3, 4, 5 zeros. So it becomes 1, 2, 3, 6, 4, 6, 1. That's the energy before. The energy after is simply going to be a half v squared. So it's going to be 40 times 25, which is move the 10 across to the other one, which is going to be 1,000. So I knock 1,000 after that, and it's 16630 is the energy lost to work done due to friction. So the answer is D. Okay. Uh, 36. Fixed points in the surface and ocean 6 apart. Ocean wave travels in the direction P to Q. Frequency that travels at constant speed. A wave peak passes Q at T equals 0. The next wave peak traveling towards P. Okay, so situation 1 is it has a peak there, and then that peak crosses there later. So the distance between the peaks, so that peak initially had 0.8 seconds before it even got to P. So distance is speed times time plus 6 is the wavelength. So I know the wavelength is 6 plus 0.8 v for the wave speed. And I know that V equals F lambda, so lambda is V over F, which is 2V. So 2V equals 6 plus 0.8V, which means that 1.2V is equal to 6, which means that V is equal to 5, which is C. That was complicated. I wish I'd skipped that. Okay, so here, radioactivity. This is kind of feeling like a not too great. Nope, I'm not allowed to think about how it's going until it's done. So, one radioactive isotope, single step, half-life 120. Radiation detector, which measures the count rate. Okay, so this is going to be, so the count rate plus the background is 910. After 240 minutes, which is 2 half-lives, the count from the source will be a quarter of the count from the source, and that has dropped to 238. In other words, that drop of 276 is 3/4 of the count rate. And after a further okay, so well, this is just solving it. So let's divide that by 3 to give you 2 to 4 equals C over 4. So 6, 9, 8 is the initial count rate. So the background rate for teen. Okay, so it's F, G, or H. And so this over 4, so it was at 224, and I go a further 3 half-lives, so I divide that by 8, and I'm going to be left with 28, which is the count source, and I have to add the background back, plus that would get me to 42, which is H. Jesus, damn, this is really tough. Like, it's doable, but it's tough in the time. Lots of traps, lots of easy ways to think you're done and you're not. Okay. Should have done more tactical skipping. Okay, so straight line accelerates non-uniformly. All right, what speed does it end up on? It ends up at going 30 meters in 5 seconds, so it ends up on 6. So the change in speed is 6 over a change in time of 5. The average acceleration is 1.2. And the average resultant force, therefore, is equal to 800 times the 1.2, which is 880 times 12, which is 960, which is D. Okay, back on track. I'm going to let that win give me a sense of momentum. Kind of think I've settled nicely into the paper. I tie it into a rectangular box with those dimensions. Solid concrete or solid steel. There are twice as many steel cubes. Okay, so the volume of that is 8 centimeters cubed per thing. The volume of that is 720 centimeters cubed total to fill, which means there are 90 cubes. There are twice as many steel cubes as concrete, so there's 60 steel and 30 concrete. Grams per. So, in other words, 480 centimeters cubed of steel and 240 centimeters cubed of concrete. So multiply the concrete by 2, you get 480 grams. Multiply that by 8. Ugh. 48 times 8. I'm going to say that's 50 minus 2 times 8. So it's going to be 40. And then multiplied all by 10 at the end. So it would be 400 minus 16, which is 384. Stick a 0 on the end. So that is of the steel. Total mass of the cubes. So it's that plus the 4. There's certainly a faster way I could have done this, I'm sure. 934, 320 is E. Okay. Doesn't matter, I got there. Points are points. So 32 electromagnetic waves that travel at that with wavelengths in that range. Okay, so lambda is V over F. So 3, 10, 8 all over 6, 10, 12 is 0 0.5, 10 minus 4, which is big. Because these are 4 times 10 to the minus 7, and this is 5 times 10 to the minus 5. Okay, so, and then the other one is 3, 10, 8 all over 6, 10, 14, which then becomes 0 0.5 times 10 to the minus 6, which is 500, which is 5 times 10 to the minus 7, 500 nanometers, which is invisible in the visible region. So it's certainly infrared and visible, but not ultraviolet, which is B. Okay. Come on, two trolleys. So one trolley has a mass of 8, traveling to the right at 4. So there's 32 momentum that way. And it's traveling to the left, so there's 2 momentum that way. So there's 30 momentum overall acting to the right. They collide and stick together, which is then, so then the speed that way is 3 with a mass of 10. So before we have a half times m times v squared is 4, giving me 64. And here half m times v squared is 1. So before we had 65 joules of kinetic energy, and after we have half times m times v squared. So after we have 45 joules, so 20 joules is lost, which is C. Apologies, it's not very clear. I'll redraw that clearer later, but I feel like I have time to catch up. 30. 12-volt battery. Okay. Temperature is 10. The current is that. Thermistor, fixed resistor. 12-volt battery. The resistance of the thermistor varies with temperature. So 10 degrees C. I know I'm at 400 ohms. Let me draw this out. 12 thingy. I can't be bothered to draw it correctly. So that's going to be R. We know that's going to be 400. We know 25 milliamps. So V equals IR. So our total is V all over I. Multiply top and bottom by 4. That would give me 100. So multiply by 10. For total is that. So this resistance is 80 ohms. When the thermistor is at 60, 70, 80, that becomes 40. So the total becomes 120 in total. The current is therefore going to be V over the, which is 100 milliamps, which is option C. Okay. So this immediately looks very left-hand rule-y. Okay, so we need to force and direction. So F equals BIL is the equation to use. F equals B times I times L, doing it in meters, which then becomes 1.2 times 0.12, which is 12, well, 0.144 newtons. And that is equal to the weight of that. So therefore the mass is 0.04 times A. So in fact, we can multiply both sides by 100, call that 4, call that 12, call that 14.4 is 4a. No, I'm okay. So 4a is 12 times 1.2, cancels 3, a is 3.6. Good, those are options. And let's left-hand rule this. Positive. So the current, let's start with the field. So the field is directly into the page. Field, okay, current is going to go from positive to negative, so it's going to be down. So the force is going to be to the right. So it's 3.6 to the right, F. Okay. Okay. So transform a question. Think. NPIV. PIV. Okay, so that's 240, and that's 12. You know the power is the same. The current in the primary coil is 0.1. So P equals IV is 24. Is 24. This current is 2. Before, that's the before case. In the after case, the resistance goes to half the resistance for the same voltage. So the current doubles up to 4. That stays the same. That therefore doubles up to 48. What is the current in the primary coil now? Well, that's going to, for the same voltage, that's doubled up to 48. That's doubled up to 0.2, I think. And the current in this lamp will not have changed because the resistance has not changed. The voltage on it has not changed because it's in parallel. So the current is the same, which is still 1. So 0.21 is D. I'm going to lock that in. 27. Okay, the first country supplies electricity at a voltage of, so the power in is 410.3 times 210.3 is 800 times 10 to the 6. Receives electricity at that is 160, 10.3, 60 times 410.3, 640, 10.6. Efficiency is 640 over 800. Cancel the 0, cancel for 8s over 10, which is 80%. Efficient. Energy wasted per minute is going to be 160 times 10 to the 6 is the power times 60 seconds, which is 9600 10.6, which is 9.610.9. 9.610.9 with 80% efficiency gives me D as my answer. Okay, 26. Stabilize the tip with that. How many beta decays are made in decay of 1 to form that? Okay, well, let's look at what's happened to the mass. No, yeah, in the mass. So if 238 went to 206, that is a drop of 32, which is achieved by 8 alphas. This would have resulted in a drop of 20 in the proton number, and 10 protons have to be gained back in order to get it up to 82, which means that 10 betas have to have been emitted. Okay. The surface of this wall is shiny. Shiny, this is a radiation question. Thermal radiation. These features insulate the liquid nitrogen by reducing the way at which thermal nitrogen is transferred to liquid nitrogen. How does it help insulate it? So the shiny inner surface of the inner wall is a good emitter. No. It's a bad emitter. Thermal radiation cannot, yes, it can travel in a vacuum. Is a poor absorber. Well, it is a poor absorber because it's a good reflector. Is that why? It is true. But is it why? I'm going to say yes. I'm going to say 3 only. I could be wrong on that, but I'm going to say D. So I know it's true. I'm not thinking very clearly now about whether it's something else. So I'm willing to take the gamble on that. In the interest of time, ideal gas. So piston is now pushed into the gut, occupies half of its original volume. So P1 V1 equals P2 V2. But V2 is a half of V1, so the V1s cancel. So P2 is 2P1. Oh, wait, this was a bit silly. Because it's the same temperature, the average speed of the particles is exactly the same. And because the pressure is doubled, they collide with the surface of the piston twice as frequently. So the answer is F. Okay. Ugh. Right, I do tend to like refraction. Direction of the waves of the regions separated by one wavelength. Okay, angle of incidence is going to be perpendicular to that. So if that is theta in there, that is 90 minus, let me draw this a bit bigger. If that is theta, that is 90 minus theta, which means that the angle of incidence to the normal is still theta. And by that same logic, on this other side, if that is theta, then to here, that would be 90 minus theta, and then that would be phi. So angle of incidence is theta, angle of refraction is phi. So it's A or B. And the speed, well, the frequency doesn't change. V equals F lambda. So V is proportional to lambda, so it's faster where there's the bigger wavelength, so it's faster in X, so it's A. I'll go through more detail later. Soldering iron. Because I'm C delta T. Right, so we have M power time. Increases by that. Multiply those two, you're going to get 1500 joules is M C. Oh, delta T. So let's work out, in fact, Q. That actually goes into the tip itself. C delta T. So 400 squared, 16, 1, 2, 3, 4. That's kilogram, that's grams. That felt off. So what should, okay, let me try this again. So M in kilograms times C times delta T. So knock 3 zeros off to make that happen. So it becomes 4 times 40, which is 160 joules, actually goes into the copper. But in terms of transfer, it's 30 times 50, which is 1500 joules is transferred by the electricity. So a full 1340 is wasted. Inefficient. All right, next. Final question of the first pass. We do not have a huge amount of time. So 21. Okay, charged atom. So that's an ion of an isotope of an element. So because it's an ion, it can have the same number of protons and electrons. So the whites are protons. Different isotope of the same element has to have 3 oppositely charged ions. So it's going to have 3 protons, 2 electrons, and not 4. So 3, 2, and not 4. That's B. That works. Okay. Going to lock that in. I don't have time. So I got 5 minutes to handle anything I haven't handled. Yep, 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 yep. Yeah, yeah, yeah. Mm-hmm. Yeah, 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 yeah. Maybe I have less than I need thought. Yes. I thought I skipped one on the way. Oh well. Maybe I didn't. All right, let me do at least 39. I know I haven't done 39 and 40. Okay. So here, in 1 second, a certain mass has been ejected with speed v, which means per second, it is gaining the same momentum. So that should be constant, which means that the resultant force is constant. But F equals ma, and A equals F over m. F is constant, but m is decreasing, which means that A is increasing. But m will be decreasing. I thought m will be decreasing at a constant rate. So A should be. They're inversely proportional, which means it's going up that. So it should be increasing at an increasing rate, which is A. Not at all confident on that, though. And then 40. In the real thing, I might flag that to come back to. And strangely, a spring constant that. The spring is suspended, so it's vertical, and a load is attached at the end of the spring. Pulled vertically downwards until the length is that. Release. What is the speed of the load at the instant the spring returns to its unstretched length? Okay. So what's happened? It's been stretched to here. Energy is a half k x squared. 10. So it's 0.4 joules of energy. When it returns to its unstretched length, so that energy then goes into, well, first of all, when it's unstretched length, it goes up to there. The change in GP is at m g delta h makes that 0.5. So 0.1 joules has to go into raising that. So 0.3 joules is left for the kinetic energy, which is a half times m times speed squared. So half, okay, so that, first of all, let's make that 30 and that 5 by multiplying by 100. So 60 is 5v squared. I think it's root 12, therefore, which is g. I only have a minute 15. Let me just check I have answers for everything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Answer submitted. 1 minute left on the clock. I'm going to stop the time there. Whew, that wasn't fun. That was not fun at all. Let me check my split times because that might explain why I wasn't having fun. So I had a 10-second skip followed by a 17-second skip. Split times here. So 117 was fine. Followed by a 135. followed by a 144. These are not great first pass splits. So that explains why I wasn't feeling great. I felt time pressured. Yeah, followed by a 209. Which is actually really a 210, looking at the clock and rounding properly. Okay, I caught some time back up with a 48-second split, then a 140, then a 117. Then a 103. So I'm catching up sometime here. This was getting better, but still, I don't think at any point it was easy. So this is probably the hardest section of this run, certainly. 134. Then we've got a 149, followed by a 147. So again, not great in terms of speed. I'm wondering where I built all my time up. 120. Well, this is one of them. So I got this one. That felt good. That was a 45 seconds. So I built some time bank there. Yeah. Then a 105. Yeah. Then a 57. Followed by a 126. Then a nice quick 48-second. Then I went back here and I spent 148 on this and a 214. So looking at the splits, like I can explain what, yeah, that explains why it didn't feel good. And I'm not at all confident I'm going to get 100% on the actual content here. So let's see if I made any mistakes and if there's anything I could have done to prevent that moving forward. Zooming in a little better so you can see my work. Let's get the answers. So 38 was G, which I got correct. Again, I'm going to go through and see if I can explain these better. So up thrust is the weight of water displaced. Weight of water is the volume of water times the density to give you the mass of the water times G. So that's why that was rho LV up, rho LVG upwards, rho SVG downwards. And this drag force KRV, where my R looks like a V, and I apologize for that. So terminal velocity is when the weight equals the resistive forces, and you rearrange to make V the subject. So it wasn't too bad, and I like that as a first question. This one, I think I explained it okay. Energy before comparing to energy after. Is the answer D? Yes, it is. This one I need to explain better. So it made sense in my head, but now let me make it make sense to you. So here, let's say a wave is doing something like this. Then sometime later, it's obviously going to be doing something like this. The point here is that initially, this is where Q is. And this is where P is, 0.8 seconds later. So what that means is this is 6 meters, and this distance is speed times time. So that's why the wavelength is 6 plus 0.8 v. And because v equals f lambda, lambda is also equal to v over f. And dividing by a half is the same as multiplying by 2. So I sub that in. So 2v equals that, and then you rearrange. So hopefully that's a clearer explanation when I have the time to do it. I'll just check again. The 36 was C. Good. So 35. I so nearly didn't add the background rate back in. It's really easy to forget about the background rate in questions like this. So that difference, that is 672, is due to the 3/4 C that was lost by the decay. So you can get what the background, the initial rate was, add the background back in. Well, and from that, find the background, which should have been 14. Let me just check I got it right first. 35H, yes. Okay, so I got my background rate. I then worked out this was C over 4 and a further 3 half-lives from there, divide that by 8. So this was the true count was 28, but I nearly fell for it. I nearly went for G, and then I remembered at the last second, nope, got to add the background rate back in, and got my H. So moving on to 34 then. So you have to, it's non-uniform. You have to work out the final speed, which I did quite well. I got that it was equal to 6. So average acceleration, because it's an average acceleration is total speed change over total time. So that's the 6 over the 5. So I got my acceleration. F equals ma from that. Not too bad. Well, I should really start checking answers before I start my explanation, but you know, feeling confident. Where I'm confident, I'm confident. So here, 33 was E. Yep. I think I explained that quite well as I was going, actually, so I don't think I need to re-explain. 32B, correct. So you just work out the wavelengths of the total, corresponding with the frequencies given in the range. So we work out that the wavelengths vary between 500 nanometers and a lot longer than that. So that's into the IR. This is within the visible, but that is the shortest wavelength we get, so it never goes as far as ultraviolet. 31, this was just not a clear diagram at all. I apologize for that. What I should have done is done a proper sort of before and after, where that goes to, you know, so that would have been 8, that would have been 2, that would have been 10. Speed of 1 minus 2 equals 30. So that has to also be 30, which makes that a speed 3. And from these masses and speeds, you can work out the kinetic energies on one side versus the kinetic energy on the other. But fairly standard syllabus stuff there for 31 being C. All right, so moving on to 30. Again, I liked my explanation here. I don't think I need to go over it too much. Was it C? Yep. Yeah, tracking from the graph to see what the resistance is here, working out what the resistance of the fixed resistor must be, then working out the resistance after the change in temperature, and working out the current from there. Not bad. This wasn't too bad if you know the equation F equals BIL, which is in the specification. It's one of those new equations that you haven't learned in the syllabus by this point. You will cover it by the time you do your A level, but it is in there, and it's sort of intuitive from what you understand from GCSE. So you understand from GCSE that if I have, from the left-hand rule, if I have a current acting in a magnetic field that is going to create a force, how do I increase the size of that force? Stronger magnet, higher current, or more turns on the coil. And so that's what the B stands for, magnetic field strength. So you make it stronger magnet, stronger current, more length of wire in the field. So this is just putting an equation to what you intuitively understand already. So you work that through, and I just did that a bit messily, but I did, let me just check, because it was messy that I got it right. F, yes, it was. So F equals BIL. So you work out the force and equate that to mass times acceleration to work out the acceleration, and then use your left-hand rule to work out the direction. Remember, current field force. Current goes from positive to negative. So as it pertains to the diagram, we know that the current is going to be going from that to that to that. So the current at the point that is affected by the field is moving down, with the current, the magnetic field itself acting into the plane of the paper. So my thumb is pointing right, and that's the direction in which it will accelerate. Great. So moving on to 28. E, did not get that right. Okay, let me think about this. Oh my god, it's I did conceptually get it right. I did conceptually get it right, but I looked no. Okay. So, here was the mistake that I made. I did the before case, and I was correct about the fact that afterwards the resistance is going to go to a half because the of combining resistors in parallel. So combining resistance in parallel, 1 over R total is going to be 1 over R plus 1 over R, which is quite clearly 2 over R. Good job, team. Flip that back over, you get R over 2. So that's the total resistance there. The original resistance was half. So for the same voltage, if you half the resistance, you double the current. So it doubled up from 2 to 4, which did result in a doubling of the power, which over here resulted in a doubling of this current. So I was right that the current goes to 0.2. And I was right conceptually when I said that the current here will not change because it's the same voltage because it's in parallel and the resistance hasn't changed. So the current should be the same. What I did, and this is important because these are the kinds of things that can trip you up in the real thing. I looked at that and I saw a number 1 instead of a letter I. And I should have seen that the initial current was 2. And if I had, then I would have got the right answer of E. So it's those tiny things that can trip you up. And I'm really gutted by that because everything was right in my reasoning. Just didn't get myself the correct answer for it. 27 was D. Where am I? 27D. That was not too bad. 26A. Oh, I rushed that. Didn't get that right. All right, why did I get that wrong? I remember feeling time pressured as well, so I think I definitely rushed it. What did I do? So the mass drop is 32, which is 8 alphas. Oh, I'm an idiot. I didn't write it out in full, though. So that leads to a mass drop of, a proton drop of 16, not 20. Where did I get 20 from? So it should have dropped 16, but it only dropped 10, which means 6 protons were gained through beta emission. So the answer should have been A. So that was just a mental lapse because I was doing it mentally and didn't do it on paper. So that's the trap. It's as soon as your brain gets complacent, that's when you start making execution errors. So yeah, that's when it... All right, lesson learned. Sorry, paper. Now, this one I might have conceptually got wrong. So let me just check on that. I said it was D for 25. No, I got that right. So it is definitely correct. This cannot travel... Bollocks. It absolutely can travel in a vacuum. It's the entire point. It's not a good emitter. It's a good reflector. And remember that good reflectors are poor emitters and absorbers and vice versa. So being a good reflector, because it's shiny, makes it a poor emitter and absorber. So that is true. I just wasn't sure whether it counts as something that actually explains the insulation, but of course it does, because it keeps out, the whole point of it being shiny is it keeps out the radiation from the outside. So it reflects it away instead of absorbing it, and that's why it works. This, I think I explained okay in the thing. That's a common thing here, making sure, yeah, the temperature is the same, so the speed is the same, pressure doubles, so it's double the frequency of collision. This one. Well, let me actually check that first. 24, I said F, which was correct. This I said A, I got it correct. Let me make this a bit clearer, what I meant. So here, if that is theta, that is the ray going in a straight line like that. Ooh. I've been a cheapskate and I still haven't paid the £2 a month to be able to draw a straight line on this, but like, boom, there we go. So that's the normal. If that's theta, this is 90 minus theta, which means that brings us back up to theta, and that is the angle of incidence. And we can do exactly the same thing for the angle of refraction. Or if I track that forward and you do that, the angle in there would be 90 minus alpha. So I'm going to blow up this little triangle here. That's not even it. What am I doing? Hold on a minute. So that triangle will look like this. Basically that. So that's the ray. So if that's phi, this one down here is 90 minus phi. That's a right angle, so that becomes phi, which is the angle of refraction. So that's why they are the same. And like I said, speed is proportional to wavelength. So wavelength is bigger, speed is bigger. So the answer was A. Here for 22, I think I explained that quite well. And the answer was C. 21, I'll show you in a bit more, like a bit slower. And I didn't really so the fact that it's it can't, the gray ones can't be the protons because then it would not be an ion. So the white ones are the protons. We want the oppositely charged ion. So we want 3 protons, 2 electrons, and we want there to be a different number of protons. So that was B. Couldn't be this one, same isotope. Couldn't be this one, different element. Couldn't be this one, not an ion. Couldn't be this one, too many protons. Couldn't be this one, too many electrons. Couldn't be this one, too many protons. Okay, and then we went into 39, which is where things felt like they got a little dodgy. Now this one, I'd be pleased with myself. 39A. Okay, that was wild. So what's happening here is you are expelling fuel at a constant rate, which means that in every second, the same mass of fuel is being emitted at the same speed. So there's a constant in every second, a certain mass is expelled, which has been given a momentum, which means the rocket gains that same momentum. Because the mass and the speed are constant, the change of momentum is constant per unit time. So the resultant force is a constant. A equals F over m, so we can plot A versus m as this 1 over m graph. And we know the mass is decreasing, so it's going to the left on that graph. So the acceleration is increasing at an increasing rate. If I hadn't drawn that graph, I would not have got that at all. So I'm pleased I had that idea to do that. But that was wild. 40 G, which I got right. And I'm actually okay with how I explained that one. Cool. So a couple of questions wrong there overall. Let me give some sort of overall feedback. So here, what happened here? Couple questions wrong. In that one, the reasoning was right. I literally just confused an I for a 1, which is exactly the kind of thing that is good. This is why I do live solves. It's to show not just like how to do the questions correctly, but all the stupid things that can go wrong and get in your way. So if you're one of those people who every time you do a paper, you're like, oh, that felt it went really well. Why did I not get answers? Maybe it's because of stupid things like that. So thinking not just in terms of the content of your work, but just like how you lay it out, is that going to mess you up? And the only one I got wrong in the math 2 was the fact that increases by 700%, which means it ends up being 8 times bigger, not 7 times bigger. So just thinking about the question a little bit clearer there. I think that physics felt okay, but I will say every year, the feedback that I get from people doing the ESAT is it's getting harder and harder. So yes, doing all the practice papers, making sure you have a robust system that you're going to be able to apply to these papers rigorously, but also be prepared for it to be a bit tougher and for you to feel the way I felt in that physics run, where it's like, this doesn't feel like it's going well. How do I hold myself together? How do I apply my technique here to try and pick up as many marks as possible? The things I'm proudest of in that run is not even necessarily a lot of the correct answers, but the times I let myself skip a question when I was partway through it because it just wasn't worth it. It felt like it was going to take up too much time in a first run, and I was like, no, let me secure my other safe marks first before I come back to this. Hopefully with time bank, and even if I don't have time, then it's only limited to this one question. I'm not going to let this one question take 4 minutes and waste time and ruin several other questions. So that was good. So hopefully this is a good sort of something that you can take away. Again, keep applying this to your process. By the time we're done with this, I'll have hopefully done all of the papers, so that you have a sort of good sense of, you know, how to do every question. And also every time you watch me do a run, you're going to pick up a little bit more on how I've improved my process. So the first time, if you remember, I did a run, I was making so many stupid mistakes by getting the right answer and just not circling it correct. And you see that as I go, I'm picking up on those improvements I need to make and hopefully applying them to keep my average increasing. So anything you see me do, you can do for yourself, and hope you find that helpful. So I'm going to leave it there for today. I'm going to keep going on with my interview series. I'm going to set a date for that. I think this week. Let me have a little look. So this is important if you're doing something like imperial interviews, for instance. This week, I'm very likely to do interview on probably Tuesday or Thursday. I'll populate it the stream beforehand, so it should be fine if you want to tune in for that. If not, keep working. You've got ages. So anyone looking at this, you got a few months now before you get the January cycle coming up. So you got a good batch of time. Don't burn through your papers too quickly, but keep on top of the work. Master the syllabus, really go through the spec and make sure you're on top of where you need to be. And in the meantime, work hard, have fun, and I'll see you next time.